Climate change extends beyond carbon emissions. At Seahorse Point, Panama, the focus is on marine biodiversity collapse. This disruption is a critical aspect of climate change, highlighting the need for comprehensive environmental strategies. Visit ghostfoundation.com for more insights. This presentation covers the urgency of addressing pollution to prevent ecosystem collapse. Carbon mitigation buys time, but recovery of nature is crucial. Water vapor, often overlooked, plays a significant role in climate regulation. The surface microlayer, vital for ocean health, is threatened by pollution. Take a moment to breathe deeply. This simple act connects us to the environment, reminding us of the air's purity and the importance of maintaining a healthy ecosystem for future generations. Oceans provide up to 80% of our oxygen and sequester significant carbon dioxide. They are our largest carbon bank, crucial for climate stability. Understanding this role emphasizes the need for ocean conservation. Prochlorococcus, discovered in 1985, produces 20% of our oxygen. However, microplastics pose a threat to this vital cyanobacteria. Protecting marine life is essential for sustaining our planet's oxygen supply. Diatoms, made from silica, produce 45 gigatons annually and double rapidly. Their efficiency surpasses terrestrial plants, highlighting their importance in carbon cycling and ecosystem health. Coccolithophores, made from carbonate, contribute to ocean color and carbon sequestration. Producing 25 gigatons annually, they form limestone, locking out carbon and supporting marine ecosystems. Copepods, with a mass of 5 gigatons, play a crucial role in carbon cycling. Their waste sequesters carbon, with 6% reaching the ocean floor, highlighting their importance in the marine ecosystem. Reports indicate a 70% loss of nature in 50 years, risking extinction. By 2050, we face a dead planet without intervention. The loss of nature surpasses historical extinction events, emphasizing urgent conservation needs. 80% of the world lacks municipal wastewater treatment. In Europe, 90% of wastewater lacks tertiary treatment, failing to remove plastics and toxins. Addressing this is crucial for environmental health. Textile wastewater, containing pharmaceuticals and plastics, contributes to 10% of global waste. Addressing this pollution is vital for reducing environmental impact and protecting water resources. Anthropogenic CO2 and marine life loss lead to ocean acidification, the evil twin of climate change. This phenomenon poses a severe threat to marine ecosystems and requires immediate attention. Climate change is detrimental, but ocean acidification is catastrophic. This comparison underscores the urgent need to address both issues to protect marine life and global ecosystems. IPCC data confirms pH decline, threatening marine life. Ocean acidification leads to toxic conditions, impacting food supply for billions. Immediate action is needed to prevent widespread ecological collapse. Ocean acidification is a significant threat due to reduced carbonate concentrations. Without intervention, marine ecosystems face inevitable decline, impacting biodiversity and food security. Stopping ocean acidification requires more than carbon mitigation. Pollution elimination and marine life regeneration are crucial. Without action, marine ecosystems face catastrophic collapse by 2050. pH is critical for marine life. Below pH 8.04, carbonate forms dissolve, threatening ecosystems. Over 50% of corals are already destroyed, emphasizing the need for urgent conservation efforts. You can help save coral reefs. Individual actions and collective efforts are vital for preserving these ecosystems, which are crucial for marine biodiversity and global environmental health. Shifting baseline syndrome highlights the unnoticed loss of biodiversity. With over 90% of nature lost since 1900, urgent integrated strategies are needed to bend the curve of terrestrial biodiversity. Plankton are foundational to the food chain. Their rapid biomass doubling makes them crucial for oxygen production and carbon sequestration. Protecting plankton is essential for marine ecosystem stability. Since 1900, urgent integrated strategies are needed to bend the curve of terrestrial biodiversity. Plankton are foundational to the food chain. Their rapid biomass doubling makes them crucial for oxygen production and carbon sequestration. Protecting plankton is essential for marine ecosystem stability. The surface microlayer, SNL, is a crucial interface between the ocean and the sky. Covering 100% of the oceans, it plays a vital role in regulating gas transfer, including water vapor, which accounts for 70% of greenhouse gases. Despite being only 1 millimeter thick, it contains microplastics and toxic chemicals, impacting the planet's climate and marine life. The SNL is essential for marine life and climate regulation. It interacts directly and indirectly with solar radiation, affecting chemical processes from ocean to clouds. This layer influences the composition and aging of sea spray aerosols, which are critical in climate dynamics and marine ecosystems. The 1950s marked a turning point with the mass production of chemicals like herbicides and pesticides. Initially, fertilizers boosted oceanic growth, reinforcing the SNL and reducing evaporation. However, 25 years later, these chemicals began degrading the SNL, increasing evaporation and temperatures, impacting marine biodiversity. The toxic chemical revolution began in the 1940s, introducing substances like DDT and PCBs. These chemicals disrupt the SNL, affecting carbon sequestration and water evaporation. Their accumulation has accelerated climate change, highlighting the need for urgent action to mitigate their impact on the environment. Oxybenzone, a common ingredient in sunscreens and cosmetics, is toxic to marine life at 62 parts per trillion. This highlights the potential impact of everyday chemicals on coral reefs and marine ecosystems, emphasizing the need for safer alternatives to protect ocean health. The widespread use of oxybenzone poses a significant threat to marine life, with 70,000 tons potentially lethal to ocean ecosystems and 20,000 tons used annually in cosmetics. The scale of UV screen production underscores the urgent need for sustainable practices in manufacturing. Microplastics are a hidden danger in our oceans. With 21 million tons in the Atlantic alone, these particles pose a significant threat to marine life. The unseen nature of microplastics makes them particularly insidious, requiring increased awareness and action to address this environmental challenge. Marine organisms, including fish and shrimp, are increasingly contaminated with microplastics and chemicals. These pollutants are absorbed and concentrated, often mistaken for food by plankton, leading to their decline. This highlights the cascading effects of pollution on marine ecosystems. collaborative data collection project uses GeoWiz filters to monitor particles and plankton in surface waters. This initiative aims to enhance our understanding of oceanic pollution, providing critical data to inform conservation efforts and policy decisions to protect marine environments. A plankton trawl off the Canary Islands reveals significant plastic microfiber contamination. This finding underscores the pervasive nature of plastic pollution in marine environments, highlighting the urgent need for strategies to mitigate its impact on oceanic ecosystems. A water sample from the Atlantic Ocean shows unexpectedly high levels of black carbon soot and microplastics. This data challenges assumptions about oceanic pollution, revealing the extent of contamination and the need for comprehensive monitoring and mitigation strategies. Shipping routes contribute significantly to oceanic pollution. Emissions and discharges affect the SNL, altering atmospheric chemistry and impacting marine life. Understanding these interactions is crucial for developing policies to reduce the environmental footprint of maritime activities. The interaction between solar radiation and the ocean's surface influences chemical processes critical to climate regulation. Changes in sea spray aerosol composition, driven by ocean chemistry, highlight the complex dynamics between marine environments and atmospheric conditions. The SNL's role in climate regulation is profound. It affects gas transfer and interacts with solar radiation, influencing cloud formation and atmospheric chemistry. Understanding these processes is essential for addressing climate change and protecting marine ecosystems. Historical data shows a shift in atmospheric conditions around 1978, with increasing water vapor pressure and declining cloud cover. These changes correlate with rising temperatures, underscoring the impact of SNL degradation on global climate patterns. A global regime shift in marine and terrestrial life occurred in 1978, coinciding with increased humidity. The decline of key species like Arctic krill and coral reefs highlights the interconnectedness of climate change and biodiversity loss, necessitating urgent conservation efforts. From the 1950s to 1980, humidity and temperature decreased due to the SNL's reinforcement by fertilizers. However, the accumulation of toxic chemicals eventually degraded the SNL, reversing these trends and contributing to climate change, emphasizing the need for sustainable chemical management. Achieving net zero emissions by 2030 may not prevent ocean acidification or ecosystem collapse. The loss of the SNL and its regulatory functions poses an existential threat, highlighting the need for comprehensive strategies to address climate change and protect global food security. Solutions to environmental challenges include continuing CO2 mitigation, halting toxic chemical production, and adopting green chemistry. Improving wastewater treatment and promoting regenerative agriculture are also crucial. These actions are vital to prevent catastrophic environmental collapse. The SNL's critical role in climate and marine life regulation underscores the need for urgent action. By addressing pollution and adopting sustainable practices, we can protect this vital layer and ensure the health of our oceans and the planet.